Our galaxy holds more secrets than we can possibly count. The Milky Way is not just a serene river of stars. It is a cosmic zoo filled with bizarre objects that completely defy our understanding of physics. By the end of this tour, you will know 50 of the strangest phenomena hiding in our galactic backyard. We will uncover a gravitational mystery so powerful it pulls entire galaxies towards an unseen behemoth, and we will investigate a star that dims in ways no one can fully explain. Which cosmic oddity do you think will be the hardest to believe? Our journey begins with a force so immense it dictates the motion of our entire galaxy. We are racing through space at over 1,000,000 miles per hour, not aimlessly, but toward a specific, mysterious point in the cosmos. Astronomers call this the Great Attractor. It is a gravitational anomaly of almost unimaginable power, a focal point in the void that pulls not just our Milky Way, but hundreds of thousands of other galaxies in its direction. Think of it as a cosmic waterfall, with all the galaxies in our local neighborhood flowing down a gravitational slope we cannot see. The heart of this mystery lies in the direction of the Norma Cluster, a dense gathering of galaxies some 250 million light-years away. But there is a profound problem with studying it, a cosmic roadblock known as the zone of avoidance. This is the thick, dusty central plane of our own Milky Way galaxy. It acts like a dense fog, blocking our view of the universe beyond with countless stars and cosmic dust. It is as if the very thing we are trying to study is hidden directly behind a brilliant, blinding wall. For decades, this zone made the Great Attractor one of the most frustrating puzzles in astronomy. What could possibly have enough mass to pull on so many galaxies? Early theories suggested it might be a massive supercluster of galaxies, a gargantuan gathering of matter. But as our technology improved, allowing us to peer through the dust with infrared and radio telescopes, we began to see a more complex picture. The pull we feel may not be from a single object, but from an even larger structure behind it, a vast concentration of mass known as the Laniakea supercluster, of which the Great Attractor is just one gravitational anchor point. This suggests we are being drawn toward the center of our own cosmic metropolis, a web of galaxies on a scale that is difficult to even comprehend. Yet for all its immense power, the Great Attractor is not the only cosmic puzzle that challenges our view of the universe. Far closer to home, a single, unassuming star has been behaving in a way that defies all known logic. Located about 1,500 light-years away in the constellation Cygnus, a star known as Tabby's star, or KIC 8462852, flickers and dims like no other. While most stars show slight, regular dips in brightness when planets pass in front of them, this one plunges into darkness erratically. Its light can drop by a staggering 22%, a colossal amount that suggests something enormous is blocking its light. Imagine if our own sun suddenly dimmed by a fifth, plunging parts of Earth into an unexpected twilight. That is the scale of the anomaly we are observing from over 1,000 light-years away. The strangeness does not stop there. Long-term studies showed the star is also slowly but steadily getting darker over years, a phenomenon with no clear parallel in astronomy. The most famous and thrilling early hypothesis was that we were seeing the shadow of an alien megastructure, a vast swarm of energy-collecting panels built by an advanced civilization known as a Dyson sphere. This idea, while captivating, was always a last resort, an explanation to be considered only after all natural causes were exhausted. And as scientists looked closer, nature provided its own, equally bizarre answers. The leading theories now point to a colossal, fragmented swarm of comets on a wildly eccentric orbit, or a thick, uneven disk of dust and debris surrounding the star. Detailed observations of the light revealed that less blue light is blocked, which is exactly what you would expect if the material obscuring the star were fine dust, as dust scatters blue light more effectively. A solid megastructure would block all light equally. So while the alien hypothesis captured our imagination, the evidence increasingly points to a natural, if extraordinarily messy, cosmic environment. The mystery of Tabby's star is a perfect example of how the universe constantly pushes us to question, to investigate, and to look deeper, reminding us that sometimes the most compelling answers are not alien, but are hidden in the complex and chaotic processes of star formation and destruction we are only beginning to understand. But the unsettling quiet of a single strange star is nothing compared to the profound emptiness found in the constellation of Boötes. Here, astronomers have found a void so vast and dark it challenges our understanding of the cosmos itself. Known as the Boötes Void, this spherical region of space stretches for an almost incomprehensible 330 million light-years. To grasp that scale, if you placed our Milky Way galaxy inside it, you would have to travel for tens of millions of years in any direction before you encountered another galaxy. In a universe that is supposed to be filled with a great cosmic web of galaxies and clusters, this void is a staggering desert, a pocket of near nothingness. It is not completely empty, of course. Over the decades, painstaking surveys have found a few dozen lonely galaxies drifting in this immense darkness, isolated islands in a cosmic ocean. These galaxies are not gathered into clusters, but are scattered like single, distant stars in an otherwise black sky. The mere existence of such a void forces us to reconsider how matter is distributed across the universe. According to our best models of the Big Bang, matter should be spread relatively evenly, with some areas denser and some emptier, but nothing on this scale of emptiness. How could a region this large end up with so little stuff? One theory suggests that smaller voids, which are common, might have merged and overlapped over billions of years, creating one giant supervoid. Another, more speculative idea is that the Boötes Void could be the imprint of an interaction with a parallel universe, a concept that pushes the boundaries of cosmology itself. The void stands as a silent reminder that the universe is not just defined by what is there, but by what is not, a haunting emptiness that asks us what else we might be missing in the dark. Deep within that hidden core of the Milky Way, behind the very dust that obscures the Great Attractor, lies a gravitational monster. Sagittarius A is the supermassive black hole anchoring our entire galaxy, a cosmic pit with a mass equivalent to over 4 million suns crushed into a single point. For years, its existence was inferred only by the frantic dance of stars around it, but in 2022, humanity was given its first direct glimpse. The Event Horizon Telescope collaboration, a global network of observatories working as one planet-sized instrument, unveiled an image of the dark shadow at the heart of our galaxy. That haunting orange ring is not the black hole itself, for no light can escape it, but the fiery glow of superheated gas being twisted and accelerated at the very precipice of oblivion. This was the ultimate confirmation of the titan that governs our galactic home. The most compelling evidence, however, comes from the stars that dare to orbit it. One star, known simply as S2, follows such a narrow, elliptical path that it completes a full orbit in just 16 years, a blistering pace on a cosmic scale. At its closest approach, it screams past the black hole at speeds exceeding 15 million miles per hour, a fraction of a light year from total annihilation. According to the laws of physics, this extreme environment is the perfect laboratory to test Einstein's theory of general relativity. Astronomers have watched as the light from S2 stretches to longer, redder wavelengths as it struggles to climb out of the black hole's intense gravity, a phenomenon known as gravitational redshift. The star's orbit itself slowly pivots around the black hole, its point of closest approach shifting over time in a precise Rosetta pattern, exactly as predicted by relativity. This is not a serene, distant object. It is a dynamic and violent engine, actively shaping the orbits of stars and the flow of gas across thousands of light years. Even a black hole's silent dominance can be broken by a sudden, piercing signal. In the late summer of 1977, a radio telescope in Delaware known as the Big Ear was performing a routine sky survey when it recorded something that would become a legend. A volunteer named Jerry Amon was reviewing the computer printouts days later, his eyes scanning the columns of alphanumeric data, when he saw a sequence so shocking he circled it in red pen and wrote one word in the margin. Wow, that single word gave the signal its immortal name. It was a 72-second burst of intense, narrowband radio noise, exactly the kind of signature scientists predicted an intelligent civilization might use to broadcast its existence. It came from the direction of the constellation Sagittarius, not far from the galactic center itself, and it was over 1 million times stronger than the background static of space. For one brief, electrifying moment, it seemed like we might not be alone. The signal climbed in intensity for 36 seconds, peaked, and then faded away over the next 36, a perfect curve matching the rotation of the Earth as the telescope's beam swept across the sky. This pattern meant it was almost certainly a celestial source, not some local interference from a passing satellite or an earthly piece of technology. Yet after that single burst, it was gone. Decades of repeated searches in the same patch of sky have yielded only silence. The wow signal vanished as suddenly as it appeared, leaving behind one of the most enduring mysteries in the search for extraterrestrial intelligence. The debate over its origin has raged ever since. Was it a one-time message from a distant star, a cosmic hello that we heard only once by pure luck? Could it have been a military transmission from a secret satellite, though no known human technology at the time matched its unique profile? Or was it a natural, if extraordinarily rare, celestial event? Some scientists have proposed it was a signal reflected off a piece of space debris, or even the result of 2 comets that happened to be passing through that region. The comet theory, however, has been largely dismissed as the comets were not actually in the right location at the time, and such objects do not typically emit strong, narrowband radio waves. The profound silence that followed is perhaps the most compelling argument against an artificial origin. If an alien civilization were deliberately sending a beacon, why would they transmit for just over a minute and then stop forever? The very brevity that makes the wow signal so tantalizing is also what makes it so frustrating. It remains a ghost in the machine, a single, perfect note played in a cosmic symphony, leaving us to forever wonder if we were ever truly heard. While we search for signals from distant stars, the most dramatic galactic event is already set in motion much closer to home. Our own Milky Way is on a collision course with its nearest large neighbor, the Andromeda Galaxy. This is not a question of if, but when. In roughly 4 billion years, these 2 great star cities will begin a gravitational dance that will utterly transform our night sky and reshape the future of our galactic neighborhood. The process will be slow and majestic by human standards, a cosmic ballet unfolding over billions of years. At first, as Andromeda draws nearer, it will simply appear as a larger, brighter smudge in the sky. But as the galaxies begin their first close pass, the serene spiral structures we know today will be torn apart by immense tidal forces. Stars will not typically crash into one another. The distances between them are far too vast for that, but immense streams of gas and dust will be pulled into long, brilliant tails, lighting up the heavens with the birth of countless new stars. The sky from a hypothetical future Earth would become a spectacular, chaotic canvas. Instead of a single Milky Way band, there would be 2 immense galaxies stretching across the dome of the night, their spiral arms warping and merging into a single, brilliant tapestry of light. The serene darkness we know would be filled with a glowing, celestial firestorm. After this first dramatic encounter, the galaxies will swing apart, only to be pulled back together by their mutual gravity for a final, decisive merger. Over the next 1 to 2 billion years, they will settle into a new, combined form, a giant elliptical galaxy that astronomers have nicknamed Milky Way. This new galaxy will be a vast, football-shaped collection of stars, lacking the distinctive spiral arms of its parents. The quiet, orderly orbits of stars will be replaced by a more random, chaotic swarm. This galactic cannibalism is a fundamental part of how the universe evolves. Our own Milky Way has absorbed smaller galaxies in the past, and Andromeda's halo shows evidence of its own ancient feasts. This future event is simply the next most colossal chapter in that ongoing story, a reminder that even galaxies are not permanent structures, but dynamic entities in a constant state of flux. The silent echo of a galactic explosion looms over us even now. While the wow signal was a fleeting whisper, the Fermi bubbles are a permanent, booming shout etched across the sky. These are two colossal orbs of energy, one ballooning north and the other south from the Milky Way's core, each emitting a powerful glow of gamma-ray light. They were discovered quite by accident in 2010, not by an optical telescope, but by the Fermi Gamma-Ray Space Telescope, which sees the universe in the most energetic form of radiation. The sheer scale of these structures is what defies belief. Together, they stretch for an astounding 50,000 light-years from end to end, which is roughly half the diameter of our entire galaxy. If our eyes could see this high-energy light, the bubbles would dominate the night sky, covering a region as large as the constellation Orion, but with a faint, ghostly luminescence. Their very existence points to a cataclysmic event in our galaxy's past, a time when the quiet giant at the center was anything but dormant. The leading theory points directly to Sagittarius A star. Astronomers believe that several million years ago, our supermassive black hole experienced a titanic eruption, devouring an enormous clump of gas and dust in a violent feeding frenzy. This event would have blasted out two opposing jets of superheated matter and energy, punching through the galactic disk and inflating these gigantic bubbles like cosmic balloons. This was not a gentle burp, but a full-throated roar that reverberated across the Milky Way. The evidence is written in the bubble's own light, which tells a story of fast-moving particles slamming into the more sedate material of the galactic halo. This violent past reshapes our understanding of galactic life, revealing that even our own seemingly quiet Milky Way has a temper capable of epic outbursts that leave scars lasting for eons. From the galactic roar of ancient bubbles, we move to a world of silent, perfect crystal. Orbiting a dead star 25 light-years away in the Serpent constellation is a planet unlike any other, a world that might be one gigantic diamond. Known as PSRJ 17191438b, this exotic object circles not a normal sun, but a pulsar, the rapidly spinning corpse of a massive star that went supernova. The very existence of a planet here is a miracle of survival, having endured the violent death of its original star. Astronomers believe this world is the incredibly dense, crystalline core of a once giant star itself, a white dwarf that had almost all of its outer layers violently stripped away. What remains is a sphere of carbon, compressed by gravity to such an extreme degree that its internal structure has likely crystallized. Under pressures millions of times greater than those found on Earth, carbon atoms can lock into a rigid lattice, forming a diamond on a planetary scale. This isn't a glittering gemstone in the way we imagine, but a dark, incredibly dense and brutally hard celestial body, cold and geologically dead. The challenges of observing it are immense. We cannot see it directly, as it emits no light of its own and is lost in the blinding glare of its pulsar host. Its presence is known only by the tiny, rhythmic variations it causes in the pulsar's incredibly regular radio beats. This cosmic diamond reminds us that the universe can forge treasures from the ashes of stellar catastrophes, creating worlds of unimaginable composition from the fundamental forces of destruction and pressure. Even cosmic chaos can sometimes produce perfect geometry. Far from the explosive remnants of dead stars, one nebula stands out for its almost unnatural symmetry. Known as the Red Rectangle Nebula, this celestial object is a masterpiece of precision, appearing as a glowing, box-like structure crossed by a distinct X shape. It floats in the sky some 2,300 light-years away, a stark contrast to the usual billowing clouds of gas we associate with nebulae. The secret to its unique form lies at its very heart, a pair of aging stars locked in a tight orbital dance. This binary system, known as HD 44179, is the cosmic engine sculpting the nebula. The more massive of the two stars has burned through its hydrogen fuel and is now in its death throes, shedding its outer layers into space. But instead of expanding in a uniform sphere, these gases are funneled into two powerful opposing jets. Think of holding two garden hoses pointed away from each other, creating two cones of spray. The flat disk of dust surrounding the stars forces the ejected material into this precise bipolar flow, and from our distant vantage point, that flow creates the illusion of a rectangle crisscrossed by luminous rungs. Then there is the color, that deep, rich red that gives the nebula its name. This is not the typical red glow of hydrogen gas. The source of this crimson light was a mystery for decades, a spectral signature that did not match any known element. Scientists eventually discovered it was caused by a class of complex organic molecules known as polycyclic aromatic hydrocarbons. These are essentially large molecules of carbon and hydrogen, the same basic building blocks found in soot right here on Earth. Illuminated by the intense ultraviolet light from the central stars, these carbon-rich particles fluoresce with that unmistakable red hue. The red rectangle is more than just a beautiful oddity. It is a cosmic factory for the very compounds that are fundamental to life, a reminder that even in the death of stars, the ingredients for new beginnings are being forged and scattered across the galaxy. Some stars do not live quiet, orderly lives in serene clusters. They are cosmic fugitives hurtling through the galaxy at impossible speeds. One of the most dramatic examples is Zeta Ophiuchi, a colossal blue giant racing through space at nearly 60,000 miles per hour. This star is not drifting calmly, it is plowing through the galaxy like a ship at full sail, and the evidence of its incredible journey is written in the space around it. As Zeta Ophiuchi speeds through a dense cloud of interstellar gas and dust, it cannot simply push the material aside. Instead, the star's powerful magnetic field and a fierce stellar wind of charged particles slam into the cloud, piling up the gas into a brilliant curved wall. This is a bow shock, a cosmic wave that glows with the heat of the collision. From our vantage point, it looks like a perfect fiery crescent cradling the star, a testament to its immense velocity. But how did a star this massive get kicked out of its home with such violence? The most likely explanation is a stellar breakup of catastrophic proportions. Astronomers believe Zeta Ophiuchi was once part of a binary system, orbiting a partner star even more massive than itself. When that partner star reached the end of its life, it exploded as a supernova. The titanic blast would have instantly obliterated the gravitational bond holding the pair together, flinging the surviving star, Zeta Ophiuchi, away at its tremendous speed like a stone from a sling. The star's trajectory is a clue to its violent past. By tracing its path backward across the sky, astronomers can pinpoint the possible location of its origin, leading them to a suspected stellar association where such dramatic explosions occurred millions of years ago. This runaway star is a perfect example of how the death of one star can set another on a lonely, high-speed journey across the galaxy, a solitary traveler forever marked by the explosion that created it. A star that appears older than the cosmos itself presents a profound riddle. Known as the Methuselah star, or HD 140283, this ancient traveler drifts through our galactic halo just 200 light-years away, a relic from a time impossibly close to the dawn of everything. Measurements suggest it is nearly 14.5 billion years old, a staggering figure that directly challenges the universe's accepted age of approximately 13.8 billion years. How can a star exist before the universe was born? This paradox sent shockwaves through the world of cosmology, forcing scientists to question either their stellar models or their most fundamental understanding of the Big Bang. The key to its extreme age lies in its composition. The Methuselah star is a population 2 star, meaning it is almost entirely made of hydrogen and helium, with virtually none of the heavier elements that seed later generations of stars. This pristine composition marks it as one of the very first stars to ever ignite, a first-generation giant born from the primordial gases that filled the infant cosmos. Its very substance is a time capsule from an era before planets or even complex molecules could form. The initial age estimate, however, came with a significant margin of error. Refined observations from the Hubble Space Telescope and more sophisticated modeling have been crucial in resolving the tension. Astronomers realized that the star's exact distance was slightly miscalculated, which affected its intrinsic brightness and therefore its estimated age. More accurate parallax measurements brought its age down, but the most critical factor was the inclusion of oxygen in its stellar atmosphere. Even this tiny amount of a heavier element, previously unaccounted for, changes how opaque the star's outer layers are, which in turn affects how it burns its fuel and how old it appears to be. With these new data points, the Methuselah star's age has been adjusted to just over 13.5 billion years, comfortably within the age of the universe, albeit by a cosmologically narrow margin. This celestial elder no longer breaks our models of the cosmos, but instead perfectly confirms them, standing as a silent, enduring witness to the very first moments of creation. But the Fermi bubbles are not the only ancient scars from our galaxy's turbulent core. Emanating from that same central region are structures of an even grander scale, colossal fountains of energy known as the galactic geysers. Discovered through their faint radio wave emissions, these are twin chimneys of superheated plasma that stretch for a staggering 45,000 light-years above and below the galactic plane. If you could see them in radio light, they would appear as vast, ghostly columns, connecting the brilliant gamma-ray orbs of the Fermi bubbles to an even larger, fainter halo of gas that envelops the entire Milky Way. It is a breathtaking sight, a cosmic plumbing system on an almost unimaginable scale. The geysers act as conduits, channeling energy and matter from the very heart of the galaxy out into the distant galactic halo. This is the clearest evidence yet that our galaxy breathes, in a sense, expelling material from its core in a cyclical flow that shapes its evolution over billions of years. But what cosmic engine could possibly power such immense structures? The leading theory points to a period of frenzied activity in the galactic center, a starburst event where stars were born at a rate hundreds of times faster than today. The combined effect of countless supernova explosions from these short-lived, massive stars would have pumped a titanic amount of energy into the surrounding gas, forcing it to surge upward and downward to form these colossal pillars. An alternative and equally compelling possibility is that our supermassive black hole, Sagittarius A, had multiple feeding frenzies, with each eruption contributing to the construction of these vast outlets. The geysers and the bubbles together paint a dramatic portrait of a galaxy with a violent and active heart, one that occasionally erupts, shaping its own destiny and scattering the seeds of future stars far into the emptiness of intergalactic space. Hidden in the crowded core of the Milky Way, a new class of ancient stars has been quietly exhaling. Astronomers have nicknamed them the Old Smokers, and they are rewriting the final chapters of stellar life. These are not brilliant, short-lived giants, but cool, elderly red giants that have settled into a strange and lazy retirement near the galactic center. For decades, they remained virtually invisible, their faint, reddish light blending into the dense stellar background. Their secret was only uncovered through long-term monitoring, which revealed their bizarre habit of dramatically dimming for months or even years at a time. The cause is not a passing planet or a companion star, but the star itself. An old smoker will, without warning, puff out an immense, thick cloud of cosmic soot and dust, a shroud that completely obscures its own light from our view. Imagine a candle suddenly surrounding itself with a blanket of black smoke, only for the smoke to slowly dissipate and reveal the flame once more unchanged. This is precisely what these stars do. They are cosmic chimneys, periodically belching out vast quantities of condensed material. The composition of these clouds is what makes them so vital to the galaxy at large. They are rich in complex elements like carbon, oxygen, and nitrogen, the very building blocks of planets and ultimately life. For billions of years, these ancient stars have likely been seeding the galactic center with these crucial ingredients, distributing them through their smoky exhalations. This slow, rhythmic process suggests a previously unknown method of element dispersal, one that is far more gentle and widespread than the violent explosions of supernova. The silent, patient work of these old smokers may have been fundamental in creating the chemical richness necessary for worlds like our own to form, a quiet contribution from some of the galaxy's most retiring and mysterious elders. Deep within the chaotic dance of stars around our galaxy's heart, a strange and formless entity is being stretched to its limit. This is Object X7, a dusty, elongated cloud of gas and dust on a fatal trajectory, orbiting just a few hundred times the Earth-Sun distance from Sagittarius A star itself. For 2 decades, astronomers have watched as this bizarre object has transformed before their eyes, its shape evolving from a compact blob into a long, thin streamer, like cosmic taffy being pulled apart by an invisible force. The central mystery is what X7 actually is. The leading theory suggests it is a simple cloud of gas and dust, perhaps the remnant of a recent stellar collision or the ejected envelope of a dying star that has wandered too close to the black hole's immense gravitational grasp. As it falls closer, the difference in gravitational pull between the side nearest the black hole and the side farther away, an effect known as tidal forces, is literally tearing it to shreds. But there is a competing and equally fascinating idea. X7 might not be a simple cloud at all, but a star shrouded in its own violent history. It could be the product of a stellar merger where 2 stars collided and spun together, throwing off a massive, dusty cocoon that now hides the central star from our view. This would explain its initial compactness and the steady stream of material it seems to be losing. The object's orbit is its death sentence. It is on a highly elliptical path that will bring it to its closest approach to the black hole around the year 2336. As that date draws nearer, the tidal stretching will only intensify. The cloud will grow longer and more tenuous, its material heating to incredible temperatures as it spirals inward. Eventually, it will cross the black hole's event horizon, the point of no return. Before it vanishes forever, the violent compression and heating of its gas will likely trigger a final, faint flare of X-rays, a brief cosmic scream signaling its demise. The destruction of X7 is not just a spectacle, it is a unique experiment. By watching how the black hole consumes this object, astronomers can learn precisely how the tidal forces at the galactic center dismantle matter, a process that might be happening all the time but is rarely this easy to observe. This strange, dissolving cloud offers a front-row seat to the final moments of a cosmic snack, teaching us about the fierce appetite of the silent giant that rules our galaxy. From the patient exhalations of ancient stars, we leap to the cosmic fireworks of entire galaxies being born. Amidst the countless islands of stars catalogued by automated sky surveys, astronomers found something that should not exist. They were tiny, compact, and shockingly green, earning them the whimsical yet precise nickname Green Pea Galaxies. These are not the majestic spirals we imagine, but small, lumpy, and incredibly intense stellar nurseries, some no larger than a tenth the size of the Milky Way. Their bizarre green hue does not come from alien plant life, but from a specific physical process happening at a ferocious rate. Within these galaxies, newborn stars are so massive, hot, and numerous that they flood their surroundings with a torrent of ultraviolet radiation. This intense energy strips electrons from the oxygen atoms floating in the galactic gas, a process known as ionization. When those electrons eventually recombine with the atoms, they release a very specific shade of brilliant green light, a beacon of extreme stellar activity visible across cosmic distances. This makes them perfect living fossils, cosmic time capsules that allow us to study the universe's most fecund era. The early universe was filled with similar, small, chaotic galaxies, furiously forging the first generations of stars from pristine hydrogen and helium. The green peas are their closest modern relatives, offering a rare, nearby window into the violent and creative processes that built the first structures in the cosmos. They are engines of transformation, converting vast reservoirs of gas into stars at a rate hundreds of times faster than our own placid Milky Way. In their brilliant green glow, we see the face of the infant universe, a time of raw, unfettered creation that shaped everything that was to come. A ghostly green cloud hangs silently in the void, a celestial apparition with no stars to call its own. This is Hanny's voorwerp, a Dutch word meaning Hanny's object, and its discovery story is as remarkable as the object itself. It was not found by a professional astronomer with a powerful telescope, but by a school teacher named Hanny van Arkel. She was participating in the online Galaxy Zoo project, classifying images of galaxies from her home computer, when she spotted a strange, glowing green smudge next to a distant spiral galaxy. Her simple question, "What is this?" launched a major astronomical investigation. The answer revealed a cosmic ghost story. The voorwerp is a vast intergalactic gas cloud, a leftover fragment from an ancient galactic collision. But its brilliant green glow is not generated from within. It is illuminated by a light that has already gone out. The nearby galaxy, IC-249, once housed a brilliant quasar, a supermassive black hole in a ferocious feeding frenzy, blazing with enough light to outshine its entire galaxy. That quasar has since fallen silent, its energy source seemingly switched off. The light we see from the voorwerp is an echo, a fossilized memory of that past eruption. The ultraviolet radiation from the long-dead quasar traveled for tens of thousands of years, striking the cloud and ionizing the oxygen within it, causing it to fluoresce with that same eerie green hue we see in the green pea galaxies. The light from the quasar is gone, but the cloud continues to glow, a testament to an event that is already over. This phenomenon offers a rare and precious glimpse into the life cycle of active galactic nuclei. Quasars are not eternal. They flicker on and off as their fuel supply fluctuates. Hanny's voorwerp acts as a cosmic mirror, reflecting a chapter in the galaxy's history that we would have otherwise missed entirely. It shows us that even the most violent monsters in the cosmos can fall quiet, their final roars echoing through space long after they have gone silent. A silent storm is passing through our cosmic neighborhood right now. It is a hurricane of stars and something far more mysterious, a river of dark matter flowing through the very space our solar system occupies. This colossal stream, known to astronomers as the S1 stream, is the shredded remnant of a small galaxy that ventured too close to our own. Billions of years ago, the immense gravity of the Milky Way reached out, captured this dwarf galaxy, and began to slowly tear it apart, stretching its stars into a long, thin current that now orbits our galactic center. Our Sun, along with every other star in our local region, is currently sailing through this river of ancient stars and invisible matter. But the stars are just the visible tracer, the foam on the surface of a much deeper wave. The true substance of this storm is dark matter. The original dwarf galaxy was, like all galaxies, embedded within a vast halo of this elusive material. As the galaxy was ripped apart, its dark matter was stretched out alongside its stars, creating a concentrated, high-speed flow directly through our part of the galaxy. This presents an unprecedented opportunity, a natural experiment happening right on our cosmic doorstep. For decades, scientists have been trying to detect dark matter particles with sensitive instruments buried deep underground, hoping to catch a rare interaction. The S1 stream offers a potential shortcut. The hurricane means the local density of dark matter might be significantly higher here than we previously assumed, increasing the odds that a particle might finally reveal itself in a detector. It is as if we have been trying to catch a few scattered raindrops, and suddenly we have learned we are standing directly in a dense downpour. While this dark matter wind is completely imperceptible to our senses, its passage is a profound reminder that our solar system is not isolated. We are dynamic participants in a living, evolving galaxy, one that still bears the scars of ancient collisions and continues to reshape itself in the dark. The serene retirement of ancient star clusters is disrupted by a glaring anomaly, stars that simply refuse to grow old. In these vast, dense gatherings of stars, all born from the same primordial cloud, you would expect a certain cosmic uniformity. The most massive stars should have burned out long ago, leaving behind dim red dwarfs and cooling white dwarfs. Yet scattered among these elderly populations are brilliant, hot blue stars shining with the vigor of youth. Astronomers call them blue stragglers, and they are the ultimate cosmic rebels, flouting the fundamental rules of stellar evolution. How can a star appear billions of years younger than its siblings? The answer lies not in defying physics, but in a stellar reinvention. These old stars have found a way to turn back their internal clocks, and the leading theories are as dramatic as they are elegant. The first is a story of cosmic violence, a stellar collision. In the crowded core of a globular cluster, stars can swing perilously close to one another. Occasionally, two older, slower burning stars will slam together in a cataclysmic merger. Their combined mass creates a single, new, more massive star. This new star, with a fresh supply of hydrogen fuel at its core, ignites with a hotter, bluer flame, effectively restarting its life cycle and standing out starkly against its cooler, redder neighbors. The second theory is a tale of stellar vampirism, a slower but equally transformative process. Many stars exist in tight binary systems. If one star begins to swell into a red giant as it ages, its outer layers can be gravitationally siphoned off by its smaller, denser companion. This transfer of mass rejuvenates the smaller star, feeding it fresh hydrogen and increasing its mass and pressure, causing it to heat up and turn blue. The donor star is left as a stripped-down remnant, while the recipient becomes a brilliant blue straggler, shining with stolen fuel. These stellar rebels are more than just oddities. They are proof that even in the ancient, seemingly settled neighborhoods of our galaxy, drama and renewal are always possible, rewriting the life stories of stars long after they were supposed to be set in stone. The same black hole that shreds clouds like X7 can also act as a cosmic slingshot, firing stars out of the galaxy entirely. These are the hypervelocity stars, and they race through the void at speeds exceeding 1 million miles per hour, fast enough to escape the Milky Way's gravitational pull forever. Their incredible journeys begin in the chaotic stellar dance around Sagittarius A star. Most often, these doomed stars were once part of a tight binary system, two stars orbiting one another closely as they skirted the edge of the monster black hole. If their path brings them just a little too close, the black hole's immense gravity can violently disrupt their dance. It captures one star, pulling it into a tight, doomed orbit, while flinging its companion away with a tremendous transfer of orbital energy. This three-body interaction is a gravitational masterstroke, a precise celestial maneuver that ejects the star with a velocity so great it becomes unshackled from the galaxy itself. Imagine a ball on a string being swung around your hand, only for the string to suddenly snap, sending the ball flying off into the distance. That is the fate of these stellar projectiles, launched from the most powerful catapult the galaxy can offer. We can trace their paths backward across the sky, and for many of them, the trajectory leads right back to the galactic center, confirming their violent origin story. Studying these runaway stars provides a unique map of the galactic gravitational field. By observing how their speeds change as they climb out of the Milky Way's gravitational well, we can measure the total mass of our galaxy, including the vast, invisible halo of dark matter that holds everything together. These lonely travelers are not just celestial curiosities, they are high-speed probes sent on one-way missions to chart the true, hidden weight of our cosmic home. Far beyond the last known planets, in the frigid darkness at the edge of our solar system, a ghost is pulling strings. The orbits of small, icy worlds in the distant Kuiper belt are not randomly scattered. Instead, they cluster together, their elongated paths all pointing in roughly the same direction and tilting in a similar way, as if guided by an unseen shepherd. This peculiar alignment is the primary clue fueling one of astronomy's most captivating modern hunts, the search for a hypothetical giant known only as Planet 9. This would not be a small, rocky world, but a colossal planet with a mass up to 10 times that of Earth, tracing a vast, lazy orbit so far from the Sun that it would take 10 to 20,000 years to complete a single journey around it. At such a distance, it would reflect almost no sunlight, making it a true shadow world, nearly impossible to spot with current telescopes. The evidence for its existence is purely gravitational, written in the synchronized dance of these far-flung objects. Without a substantial planet's gravity to orchestrate them, their orbits should be chaotically oriented. The fact that they are not suggests something massive is herding them, maintaining this strange celestial order across billions of miles of empty space. The search for this phantom planet has consumed astronomers for years, requiring them to scan vast areas of the sky for a single, faint, slowly moving point of light. It is a painstaking process, like searching for a single specific grain of black sand on a dark beach at night. Yet, despite the compelling orbital evidence, Planet 9 remains elusive, and not everyone is convinced it is there. Skeptics propose that the observed clustering could be a statistical fluke, an illusion created by observational biases. They argue that our telescopes have only mapped a tiny fraction of these extremely distant objects, and that the apparent pattern might simply vanish as we discover more. Others have suggested that the collective gravity of many smaller, unseen objects could be responsible, eliminating the need for a single large planet altogether. This debate lies at the very heart of the scientific process, a constant tug of war between a bold new theory and the demand for incontrovertible proof. Whether Planet 9 is finally found or eventually explained away, its ghostly presence in our models has already reshaped our understanding of the solar system's final frontier, reminding us that the most profound discoveries often begin not with a clear sighting, but with the subtle, persistent whisper of gravity itself. The silence of deep space was shattered by a starquake. In April 2020, a dead star known as SGR 1935 plus 2154 convulsed, releasing a millisecond burst of energy so intense it temporarily scrambled the detectors on satellites orbiting Earth. This was no ordinary tremor, it was a rupture on the surface of one of the most terrifying objects in the universe, a magnetar. These are the collapsed cores of massive stars that went supernova, but with a ferocious twist. A magnetar is a neutron star that has been cranked up to 11, a stellar corpse possessing a magnetic field of almost unimaginable power. To grasp the scale, the magnet that holds a note to your refrigerator is about 1 Gauss in strength. Earth's own protective magnetic field measures less than 1 Gauss. A typical neutron star might have a field of 1 trillion Gauss, but a magnetar like SGR 1935 operates at a level 1,000 times stronger than that, a staggering quadrillion times more powerful than Earth. If one were to magically appear halfway between Earth and the Moon, its magnetic field would be strong enough to strip the information from every credit card on the planet. This unimaginable force is the engine behind its violent outbursts. The magnetar's crust, a lattice of iron nuclei 10 billion times stronger than steel, is under constant, excruciating strain from this internal magnetic field. Occasionally, the stress becomes too much and the crust cracks. This starquake releases pent-up energy, shaking the star and violently twisting the magnetic field lines anchored to its surface. The result is a flare of radiation across the electromagnetic spectrum, from X-rays to gamma rays, a scream of energy from a dying star's tortured corpse. But the most profound aspect of the 2020 event was not just the starquake itself. For the first time, a magnetar in our own galaxy was caught in the act of producing something that had puzzled astronomers for over a decade, a fast radio burst. These are fleeting blasts of radio waves that release more energy in 1,000th of a second than our Sun does in an entire day. Most come from billions of light years away, their origins completely unknown. When SGR 1935 shook, it emitted a twin blast, a flare of X-rays accompanied by an intensely bright pulse of radio waves. This single observation provided the first concrete proof that at least some of these mysterious cosmic sirens are born from the apocalyptic magnetic fury of magnetars. This single object, a city-sized remnant of a stellar explosion, connects the slow, crushing death of a star to the most fleeting and energetic signals known to science, a reminder that even in the grave, a star's magnetic heart can still beat with terrifying power. This familiar pattern of stars, known as the teapot, offers a celestial guidepost for anyone gazing toward the heart of our galaxy. Found within the constellation Sagittarius, this asterism is not an official constellation itself, but a simple, memorable shape that our minds easily connect. 8 bright stars form its distinct silhouette, a perfect teapot complete with a spout, a lid, and a handle, seemingly pouring steam into the richest part of the Milky Way. For countless generations, this pattern has served as a universal starting point for cosmic navigation. Simply follow the imaginary stream pouring from the teapot spout, and you are looking directly toward the galactic center, toward the hidden realm of Sagittarius A star and all the other wonders we have explored. It is a direct line of sight to the most dynamic and crowded region of our entire galaxy. But the teapot is more than just a signpost, it is a window. Pointing even a small telescope into this area is like turning a key to a cosmic treasure chest. Nestled within and around this pattern are some of the sky's most breathtaking deep sky objects. Brilliant star clusters like Messier 22 and Messier 28 glow like diamond dust, while vast nebulae such as the Lagoon and the Trifid unfold in clouds of pink and blue, stellar nurseries where new suns are being born. The reason this area is so packed with wonders is precisely because we are peering along the plane of the galaxy, looking through 1,000 light years of accumulated stars, gas, and dust straight into the core. For amateur astronomers, the teapot is a gateway, an easy-to-find landmark that unlocks a universe of discovery from a simple backyard. Its enduring charm lies in this beautiful simplicity, connecting our humble gaze directly to the most profound mysteries the Milky Way has to offer. Our own solar system is currently sailing through a local ring of celestial fire, a structure known as the Good Belt. This is not a distant curiosity, but our immediate galactic neighborhood, a vast, tilted disk of young, brilliant stars and stellar nurseries that surrounds us. From our perspective inside it, this belt appears as a bright band of famous stars and constellations arching across our sky, including many of the most recognizable names. The brilliant blue-white Sirius, the dominant star in our night sky, is a member. So too are the iconic stars of Orion's belt, along with the scorching heart of Scorpius Antares. These are not random neighbors, they are all part of this same local stellar ring, a cosmic highway of massive suns and the glowing gas clouds that birthed them. What makes the Good Belt truly strange is its orientation. Our entire Milky Way galaxy is a flat, spinning disk, and you would expect all local stars and gas to orbit in that same plane like cars on a racetrack. The Good Belt, however, is tilted by about 20 degrees relative to the galactic plane. It is as if a giant hand reached in and twisted this entire section of the galaxy, setting it spinning at a different angle. This means our Sun, while orbiting the galactic center, is also bobbing up and down through this tilted local structure, weaving our way through its stellar inhabitants and their vast cloudy cradles. The belt is a powerhouse of recent star formation. Its most famous components are the great molecular clouds where new solar systems are being forged right now. The Orion Molecular Cloud Complex, a stellar factory visible to the naked eye as the Sword of Orion, is a prime example. Within its glowing folds, thousands of new stars are igniting, their light illuminating the cosmic dust from which they formed. This ongoing activity tells us the Good Belt is not an ancient relic, but a dynamic and still evolving structure, likely no more than 30 to 50 million years old. The central mystery, the one that astronomers still grapple with, is what created this tilted ring in the first place. What colossal event could have warped our local galactic environment so dramatically? The leading theory points to a cataclysm from the distant past, the explosive death of a massive star, or even the merger of two dense gas clouds in a violent collision. This event would have sent a powerful shockwave rippling through the interstellar medium, compressing gas and triggering a wave of star formation that propagated outward, creating the ring we see today. Some scientists have even speculated that the Good Belt is the expanding shell of a prehistoric supernova, a cosmic echo of a stellar detonation that occurred long before humans walked the Earth. This local bubble of stellar activity is a reminder that our galactic backyard is not a serene and placid place, but a region still being shaped by the violent, creative forces that govern the entire cosmos. The search for Planet 9 at the solar system's edge is matched by a hunt for hidden worlds much closer to the Sun. Tucked inside the orbit of Mercury, a hypothetical band of asteroids known as the Vulcanoids might be hiding in plain sight, or rather, hidden by the Sun's blinding glare. These would be the solar system's ultimate survivors, ancient rocks that have endured the scorching proximity of our star for billions of years. Finding them or proving they do not exist would force us to rewrite the earliest chapters of our solar system's violent history. The concept is simple in theory, but the practical challenges are immense. Observing anything so close to the Sun is a monumental task for Earth-based telescopes. Astronomers have only a tiny window of opportunity during a brief twilight or a total solar eclipse when the Sun's overpowering light is momentarily blocked. Even then, the searing heat and intense solar radiation in that region create a chaotic environment that could have easily destroyed any small bodies eons ago. If volcanoids do exist, they would likely be dark, baked relics, perhaps rich in refractory elements like iron and nickel that can withstand incredible temperatures. Their orbits would be incredibly fast, completing a journey around the Sun in just a matter of weeks. The profound significance of this search lies in what these asteroids would represent. They would be pristine time capsules from the inner solar system's formation, completely untouched by the cosmic weathering that has affected asteroids farther out. Studying their composition would give us a clear picture of the original building blocks that coalesced to form Mercury, Venus, Earth, and Mars. A confirmed absence, however, would be just as telling. It would mean that the region inside Mercury's orbit was simply too violent and energetic during the solar system's youth for any material to stably accumulate, swept clean by the young Sun's ferocious output. This quiet hunt for a phantom asteroid belt reminds us that some of the most fundamental mysteries about our own cosmic home are still waiting to be solved, not in the distant darkness but in the fiery light of our own star. Even our place in the cosmic web is stranger than we ever realized. While the Boötes Void is a distant desert, astronomers have discovered that our own Milky Way floats in a vast local emptiness of its own, a region of startlingly low density now known as the KBC Void. This is not a perfect sphere of nothingness, but rather an immense bubble of underdensity, a cosmic hole about 2 billion light-years across, with our galaxy sitting close to its center. We are not just observers of cosmic voids, we are inhabitants of one. This discovery fundamentally reshapes our understanding of our local universe and solves one of modern cosmology's most nagging problems, the Hubble tension. The Hubble constant is the rate at which the universe is expanding, a critical number for understanding everything from the age of the cosmos to its ultimate fate. For years, two different methods of measuring this constant have produced stubbornly different results. Measurements based on the ancient cosmic microwave background, the afterglow of the Big Bang, suggest one rate of expansion. Meanwhile, measurements using relatively nearby stars and supernovas, which act as cosmic distance markers called standard candles, consistently give a faster, higher value. This discrepancy was a major headache for cosmologists, implying that either our measurements were wrong or our fundamental models of the universe were missing a crucial piece. The KBC Void provides that missing piece. Think of the universe as a lumpy loaf of raisin bread expanding in the oven. If you are a raisin sitting in a large air pocket within that loaf, the dough around you will expand into your local emptiness more readily than dough in a denser, more crowded region. The gravitational pull of all the matter outside the void is effectively tugging the sparse region outward, causing space within the void to expand faster than the cosmic average. Because we are inside this underdense bubble, our local measurements of the expansion rate, based on nearby supernovas, are naturally skewed toward this faster local value. The measurements from the cosmic microwave background, however, survey the entire universe and give us the true global average. The void we live in acts as a local speed boost, a cosmic hill we are rolling down that makes our neighborhood appear to be flying apart more quickly than the rest of the cosmos. This elegant solution reveals that we are not at a special, average point in the universe, but in a specific and unusual environment that directly colors our perception of reality. Our galactic home is adrift in a billion light-year pocket of quiet, a local emptiness that has been subtly tricking our measurements of the cosmos all along. Our galaxy's ancient structure was forged by a long-forgotten act of violence. Billions of years ago, a smaller galaxy, now known as Gaia Enceladus, ventured too close to the infant Milky Way. The encounter was catastrophic, a slow-motion collision that did not result in a clean merger, but a brutal dismemberment. The Milky Way's far stronger gravity reached out and utterly shredded the intruder, tearing its stars from their orbits and scattering them into a chaotic cloud. For eons, the evidence of this galactic cannibalism lay hidden, the stars of the victim thoroughly mixed with the native stars of our own halo. We could not see the forest for the trees. That changed with the European Space Agency's Gaia mission, a spacecraft tasked with meticulously mapping the positions and motions of over 1 billion stars. When scientists analyzed this treasure trove of data, a stunning pattern emerged. The stars from this ancient collision were not moving randomly. Their orbits were all highly elongated and radial, shooting out from the galactic center and then falling back in over and over. When these orbital paths were visualized in a graph, they clustered together in a distinct sausage-like shape. The butchered remains of the Gaia Enceladus galaxy had finally revealed themselves, not by their position but by their motion. This was not a gentle merging of two systems, it was a violent feast that fundamentally reshaped our galaxy. The impact injected a huge amount of energy and stars into the Milky Way's inner halo, puffing it up and giving it the structure we observe today. Many of the oldest stars in our galactic neighborhood, stars that astronomers had long studied, were suddenly revealed to be invaders from this lost galaxy. This discovery forces us to rewrite our galaxy's origin story. The Milky Way was not born in serene isolation, but grew through a series of violent acquisitions, with the Gaia sausage representing one of the most significant and formative events in its entire history. The very fabric of our galactic home bears the indelible marks of a cosmic crime seen from 10 billion years ago. Sometimes the most profound darkness is not an empty void, but a place of hidden creation. Drifting just 600 light-years away, a vast starless patch stains the luminous band of the Milky Way, a black silhouette against a river of light. This is the Coalsack Nebula, a dark nebula so dense and cold that its clouds of microscopic dust and gas completely absorb the light from the hundreds of thousands of stars that lie behind it. To the naked eye, it looks like a hole has been torn in the fabric of the sky, a profound and unsettling absence. Yet this darkness is not a barren emptiness. It is a stellar nursery in its deepest, quietest phase. Inside that cold, black shroud, gravity is patiently at work, slowly pulling the dust and gas together into dense, compact knots. Within these hidden cocoons, the pressure and temperature are steadily rising, and in a few million years they will ignite into brilliant new stars, burning away the very darkness that gave them birth. The Coalsack is a cosmic cradle, a silent, dark womb where the future of our galactic neighborhood is being slowly assembled. Long before modern telescopes revealed its true nature, this celestial darkness was deeply woven into the stories of the people who watched the southern skies. For many indigenous Australian cultures, the Coalsack was not a mere absence of light, but a vital part of their celestial landscape. It is often known as the head of the emu in the sky, a vast dark constellation whose body is formed not by stars, but by the dark patches of the Milky Way itself. In this cosmic tapestry, the Coalsack forms the emu's head, a crucial feature in a story that connects the heavens to the land, dictating seasons and guiding traditions. This profound connection reminds us that our quest to understand the cosmos is not new, and that the same mysterious darkness we study with our instruments was for millennia a familiar and meaningful character in the oldest stories ever told. We drift inside a cosmic cavity, a 1,000-light-year-wide pocket of hot, sparse gas known as the local bubble. This is not a perfect sphere, but a complex, tunnel-like structure with our solar system floating near its center. For millions of years, we have been traveling through this scorching but nearly empty region, a fact that fundamentally shapes our view of the cosmos. The story of the local bubble begins with a cataclysm, a chain reaction of stellar deaths. Roughly 14 million years ago, a cluster of massive stars was born close together in our galactic neighborhood. These stars lived fast and died young, one after another exploding as supernovae. Each titanic detonation sent a powerful shockwave blasting outward, sweeping up the surrounding clouds of cold, dense gas like a cosmic snowplow. This collective force carved out the immense cavity we inhabit today, pushing the interstellar material to the bubble's edges where it now forms the glowing, star-forming walls we see as nearby nebulae. The bubble itself is filled with a ghostly, superheated plasma, a thin gas so hot it glows faintly in X-rays, a reminder of the violent energies that forged it. This local environment acts as a protective shield of sorts. The dense, dusty clouds that could otherwise obscure our view of the wider universe are pushed far away, giving us a remarkably clear window out of the galactic plane. We can see distant galaxies and study the large-scale structure of space with less interference, all because we reside in this expansive, cleared-out chamber. Our journey through it is temporary, though. In another few million years, the Sun's orbit will carry our solar system through one of the bubble's walls, back into the crowded and murky interstellar medium. Until then, we enjoy a front-row seat to the aftermath of a celestial demolition, a silent testament to the power of dead stars to sculpt the galaxy around them. A colossal wave of primordial gas is hurtling directly toward our galactic disk, a silent tsunami on a million-year journey. This is Smith's Cloud, a massive structure of hydrogen gas stretching 11,000 light-years long and 2,500 light-years wide, a ghostly leviathan adrift in the galactic halo. It is moving at nearly 200 miles per second, and in approximately 30 million years, it will slam directly into the spiral arm of our Milky Way. This will not be a collision of stars, but a titanic meeting of gas and dust, an event that will trigger a celestial firestorm. When this immense reservoir of raw material plows into the denser gas of the galactic plane, the resulting shockwaves will compress vast clouds, forcing them to collapse under their own gravity. The outcome will be a dazzling burst of star formation, a brilliant stellar nursery igniting across thousands of light-years, birthing millions of new suns in a spectacular display of cosmic creation. The cloud's own origin, however, remains a profound mystery. For decades, astronomers debated whether it was an intergalactic wanderer, a fragment of a devoured dwarf galaxy, or a product of our own galaxy's violent activity. The key to solving this puzzle lay in its chemical fingerprint. By analyzing the light from distant quasars shining through the cloud, scientists could determine its composition. They discovered it was rich in sulfur, a clear sign that Smith's Cloud was not a pristine visitor from the void. Its heavy element content matched that of the Milky Way's own outer disk, suggesting a dramatic homegrown origin. The leading theory now is that this colossal gas structure was violently ejected from our own galaxy hundreds of millions of years ago, perhaps by a tremendous supernova explosion or the powerful gravitational forces at the galactic center. It was thrown out into the darkness, and now, like a cosmic boomerang, it is returning home, destined to deliver the very ingredients for its own spectacular rebirth. A faint, ghostly river of stars encircles our entire galaxy, a structure so vast it defies easy explanation. Known as the Monoceros Ring, this immense band of stars loops around the Milky Way's disk, tracing a path far above and below the familiar plane of our spiral arms. For years, its very nature has been a subject of intense debate, forcing astronomers to choose between two equally dramatic origin stories. The first theory paints a picture of galactic cannibalism. It suggests the ring is the shredded corpse of a dwarf galaxy that ventured too close to the Milky Way billions of years ago. Our galaxy's immense gravity would have stretched the intruder apart, pulling its stars into a long, looping tidal stream that now orbits us like a cosmic serpent, a permanent scar from an ancient feast. The evidence for this is compelling, as the ring stars are notably older and poorer in heavy elements, much like the populations found in known dwarf galaxies. The alternative theory, however, argues that the ring is not an invader at all, but a part of our own galaxy's twisted anatomy. Our Milky Way is not a perfectly flat disk. Its outer edges are warped and flared, bent upwards on one side and downwards on the other, likely by gravitational interactions with satellite galaxies or the pervasive pull of dark matter. In this view, the Monoceros Ring is simply the most prominent manifestation of this colossal warp, a ripple of our own galactic disk seen from the inside. We are not looking at the remains of a consumed neighbor, but at the flared edge of our own stellar home. The debate hinges on subtle measurements of the star's velocities and compositions. If they move in a coherent stream with a distinct chemical signature, the cannibalized galaxy theory gains strength. If their motions are more chaotic and their makeup is similar to the Milky Way's outer disk, then the warp theory prevails. This celestial detective story reminds us that even the largest structures in our galaxy can remain enigmatic, their true stories written in the faint light of ancient suns. The true scale of our galactic address is even more staggering than we have seen. Our Milky Way is not a solitary island universe, but merely one bright neighborhood within a continent of galaxies so vast its name means immeasurable heaven in Hawaiian. This is the Laniakea supercluster, a web of over 100,000 galaxies all bound together by the relentless pull of gravity, a single structure stretching 520 million light-years from end to end. Within this cosmic metropolis, entire galaxy clusters act as suburbs, all flowing along invisible filaments toward a central gravitational valley. Our journey toward the Great Attractor is not a lonely one. We are all moving together, carried on this immense river of space-time. This grand motion redefines our place in the cosmos. We are not simply a galaxy orbiting a black hole. We are part of a supercluster on the move, a single thread in a tapestry of unimaginable size. To visualize Laniakea, imagine a colossal tree with sprawling branches. The densest clusters of galaxies are the knots in the wood, while the long, thin strands of galaxies connecting them are the filaments. Our own local group, which includes Andromeda and the Milky Way, is a small twig on one of these branches located on the outer edges of the supercluster. The Great Attractor itself is not the final destination, but a powerful gravitational anchor point within this larger structure, a dense knot pulling everything in our local cosmic neighborhood toward it. This grand perspective humbles our sense of direction. The Milky Way spins, our local group drifts, and the entire Laniakea supercluster flows, all in a complex, layered dance governed by the invisible hand of dark matter. Our home galaxy is but a single leaf caught in a current that spans 500 million light-years. Floating in the void near the galaxy M99 is a ghost of pure potential, a cloud of hydrogen so vast it could form billions of stars, yet it contains not a single one. This is Boötes 21, a cosmic paradox that has forced astronomers to question the very definition of a galaxy. For years, it was completely invisible, a structure that only revealed itself through the faint whispers of its atomic hydrogen detected by radio telescopes. Its sheer mass, calculated from the motion of its gas, is staggering, yet that mass is completely disconnected from any source of light. It is a galaxy that seems to be made of nothing but the raw material for stars and an overwhelming amount of unseen matter. This profound disconnect is the heart of the controversy. One compelling theory posits that we are looking at a true dark galaxy, a celestial body held together and dominated by dark matter. In this scenario, the hydrogen cloud is simply the tracer, the visible tip of a massive, invisible iceberg of dark matter whose gravity prevented the gas from ever collapsing to form stars. It would be a galactic-scale failure, a place where the normal processes of creation never ignited. The alternative explanation is far less exotic but equally dramatic. Boötes 21 might be the cosmic equivalent of a skid mark, a long streamer of gas ripped from a larger galaxy during a close gravitational encounter. This tidal debris, stretched and set adrift, could mimic the mass and structure of a standalone object without actually being one. The debate hinges on the cloud's motion and its delicate structure. If the hydrogen is coherently rotating as a single, stable entity, it strongly suggests the presence of a dark matter halo holding it all together. If, however, its motion is chaotic and its shape is clearly the result of a recent collision, then the tidal debris model wins. For now, Boötes 21 remains an enigma, a celestial Rorschach test challenging us to decide if we are seeing a new class of object or merely the scattered pieces of an old one. It forces us to wonder how many other dark, silent giants might be drifting unseen in the voids between the stars. Amidst the chaos of galactic collisions and warped disks, one galaxy stands as a monument to perfect symmetry. Hoag's object is a cosmic bullseye, a stunningly precise ring of brilliant blue stars encircling a core of golden light, floating in the void 600 million light-years away. It looks less like a natural structure and more like a piece of celestial art, a perfect circle painted onto the black canvas of space. The central core is a dense sphere of ancient yellow stars, a population that dates back billions of years. Surrounding it is a nearly perfect detached ring of young, hot blue stars, blazing with the energy of recent birth. Between these two distinct stellar populations lies a gap of profound darkness, a clear void that seems to separate the old from the new. This flawless geometry presents a profound puzzle for astronomers. How does a galaxy form in such a perfectly divided and symmetrical way? The most common spiral galaxies, like our own Milky Way, have their young blue stars and old red stars mixed together in swirling arms. Hoag's object is something else entirely, a galaxy that appears to have been constructed in two separate, distinct phases. The leading theory points to a galactic collision, a violent event from the distant past. Billions of years ago, a smaller galaxy may have plunged directly through the center of what was then a normal spiral disk. The gravitational shockwave from this cosmic bullshot would have triggered a massive burst of star formation in a circular wave propagating outward from the center, much like a ripple expanding across a pond. This wave of compression would have ignited the ring of brilliant blue stars we see today, while the central core of older stars remained largely undisturbed. Another possibility is an extreme version of a resonance, where gravitational instabilities within the original galaxy naturally channeled gas and dust into a stable ring, which then collapsed to form new stars. What makes Hoag's object even more captivating is that it is not entirely alone. Peering deep into the gap between the core and the ring, astronomers have spotted another, much more distant ring galaxy, another perfect cosmic bull's-eye glimpse through the hole of the first. This chance alignment hints that while these perfect rings are incredibly rare, they may be a fundamental, if seldom seen, chapter in the story of how galaxies evolve, a beautiful and silent reminder that even destruction can give rise to perfect order. Even cosmic perfection can be violently undone. While Hoag's object shows the beautiful symmetry that can emerge from a collision, another galaxy shows the raw, chaotic aftermath. The Tadpole Galaxy is a cosmic animal caught mid-flight, its body warped and a colossal tail streaming behind it like a celestial tadpole swimming through the void. This is not a serene spiral, but a galaxy caught in the act of being torn apart. Its spectacular tail, a river of blue star clusters and glowing gas, stretches for an astonishing 280,000 light-years, nearly 3 times the diameter of our own Milky Way. This entire structure is a fossil record of a violent encounter. Astronomers believe a smaller, compact galaxy plunged directly through the tadpole's disk in the distant past. Think of throwing a stone into a pond, but instead of water ripples, the gravitational wake pulls out an immense stream of stars and gas. The intruder galaxy was not massive enough to trigger a full merger, but its gravity was more than enough to disrupt the tadpole's delicate structure, stirring up its gas and dust and triggering a firestorm of new star formation. The brilliant blue knots that line the tail are not random specks. They are massive stellar nurseries, entire clusters of young, hot stars that ignited as the gas in the tail was compressed. This cosmic tadpole will not regenerate into a new form. Over billions of years, the pull of gravity will likely draw this long tail back toward the main body, or it may simply dissipate into the intergalactic medium, its stars set adrift forever. The intruder galaxy itself is now a faint, receding speck, visible only with the most powerful telescopes, having delivered its gravitational blow and continued on its journey. The Tadpole Galaxy is a breathtaking snapshot of a temporary state, a portrait of cosmic violence that is both destructive and creatively fertile, leaving behind a trail of new suns as its enduring legacy. That same celestial violence that created the Tadpole Galaxy can also forge a perfect wheel of fire. The Cartwheel Galaxy spins in the void 500 million light-years away, a stunning celestial pinwheel whose symmetry makes it one of the most photographed objects in the cosmos. Its structure is breathtakingly complex, a bullseye of multiple rings that ripple outward from a brilliant core. At its heart lies a small, dense nucleus of older yellow stars. Surrounding this is a blazing inner ring of intense star formation, which is itself encircled by the galaxy's most famous feature, a vast outer ring of brilliant blue star clusters and glowing pink nebulae that spans over 150,000 light-years. This entire cosmic wheel is connected by faint, spoke-like structures of dust, completing its unmistakable cartwheel appearance. This perfect geometry was not born from a gentle process, but from a catastrophic collision. Astronomers believe that several 100 million years ago, a smaller companion galaxy took a near-perfect bullseye shot, plunging directly through the center of what was then a normal spiral galaxy. The gravitational shockwave from this event was like a stone dropped into a pond of stars and gas. The impact sent a colossal wave of dense material rushing outward from the center at incredible speeds. As this wave expanded, it compressed the galaxy's interstellar gas, triggering a firestorm of new star formation in a perfect, expanding circle. The outer ring, with its brilliant blue hue, marks the current leading edge of this stellar tsunami, a frontier where millions of new suns are igniting. The faint, spindly spokes that connect the rings are the ghostly remnants of the galaxy's original spiral arms, stretched and distorted by the immense gravitational forces of the encounter. The smaller intruder galaxy itself can still be seen, a distorted smudge of light fleeing the scene of the collision, having delivered its transformative blow and continued on its journey through the void. The Cartwheel Galaxy is a dynamic, evolving system, a snapshot of a temporary but spectacular phase in galactic life. It shows us that from a direct, violent hit, the universe can create not just chaos, but a perfect, expanding ring of new creation. Even galactic collisions can forge strange new symmetries from the chaos. Drifting in the depths of space, Mayol's object presents a sight that seems almost manufactured, a cosmic dumbbell or dog bone sculpted from the wreckage of two spiral galaxies. This is not the delicate ring of Hoag's object or the long tail of the tadpole, but a dense, double-lobed structure, a pair of brilliant galactic cores connected by a faint, luminous bridge of stars. It is a snapshot of a very specific moment in a violent merger, one that holds profound clues to the future of our own galactic home. When two spiral galaxies of roughly similar size collide, their delicate disks cannot survive the encounter. As they swing past each other in a gravitational embrace, their central bulges, packed with stars, act as anchors. These cores are so dense that they pass through one another relatively unscathed, while their outer arms are shredded and drawn out into long, flowing streams. The result is this temporary dumbbell shape, a fleeting cosmic structure that will not last. Over hundreds of millions of years, the two cores will slowly spiral inward, pulled together by their mutual gravity and the drag of the surrounding stars and gas, until they finally coalesce into a single, giant elliptical galaxy. This is the likely fate awaiting the Milky Way and Andromeda. Their first close pass will warp and tear their spiral arms, but their central hubs, where most of the mass is concentrated, will persist, just like the two lobes of Mayol's object. We are seeing a preview of a distant chapter in our own galaxy's life, a violent yet creative process that is as fundamental to cosmic evolution as the birth of stars themselves. A dead star is committing cosmic murder in the constellation Sagittarius. This is the Black Widow pulsar, a rapidly spinning neutron star that is methodically destroying its stellar partner. The pulsar, a city-sized remnant of a supernova, is incredibly dense and spins over 600 times every second, blasting its companion with a dual onslaught of fierce radiation and a supersonic wind of charged particles. The effect is like holding a blowtorch to an ice cube, but on a stellar scale. The smaller companion star, which is perhaps a tenth the mass of our own sun, is being slowly cooked and stripped away, its outer layers boiling off into space under the relentless assault. This process has enveloped the entire binary system in a vast, shimmering cloud of superheated plasma, a poisonous fog created from the vaporized remains of the victim. The Black Widow earns its name from this gruesome celestial behavior, mimicking the spider that consumes its mate. The companion star is now locked in a death spiral, orbiting the pulsar so closely that its year lasts less than 10 Earth hours. This proximity is its doom, ensuring it cannot escape the pulsar's lethal embrace. Astronomers can actually measure the destruction in real time by observing how the cloud of evaporated material periodically eclipses the pulsar's own radio signals, causing them to flicker and fade. This entire system is a stark demonstration of a star's power to reshape its environment, even in death. It presents a terrifying vision of a stellar future, where one survivor of a supernova turns its fury on its closest neighbor, creating a ghostly shroud from the ashes of its companion. A star's final breath can weave a web of astonishing complexity. The Red Spider Nebula unfurls in the constellation Sagittarius, a chaotic masterpiece of glowing gas stretching for trillions of miles. This is a planetary nebula, the luminous shroud cast off by a dying sun, but its form is anything but serene. Two vast, wavy lobes of crimson gas stretch in opposite directions, connected by a turbulent central region that looks like a celestial spider has spun a web of pure energy. The sheer violence sculpting this structure comes from the tiny, impossibly hot ember at its heart. The central white dwarf is one of the hottest stellar objects ever discovered, with a surface temperature soaring to over 300,000 degrees. That is nearly 50 times hotter than the surface of our own sun, a ferocious little engine radiating an incredible amount of ultraviolet light. This intense radiation is what makes the surrounding gas clouds glow, but it is the star's winds that carve them. The white dwarf is blasting out a supersonic gale of charged particles, a stellar hurricane moving at millions of miles per hour. These winds slam into the slower-moving clouds of gas that the star previously ejected, plowing through them and sculpting the intricate, rippled patterns we see. The waves and ripples in the nebula's lobes are like the wake from a speedboat on a cosmic lake, each one a fossilized record of a slight variation in the power of that relentless wind. This entire beautiful structure is a testament to a star's violent death, a brief and brilliant phase in the cosmic recycling process. Within a few tens of thousands of years, the glowing gases will disperse into the interstellar medium, leaving the white dwarf to slowly cool over billions of years. The red spider is a fleeting vision of cosmic artistry, a turbulent and beautiful end. A dying star's final masterpiece pales next to the raw power of a stellar nursery's natural laser. Deep within a colossal cloud of gas and dust known as W49N, a star is being born, and its violent cradle is shouting its existence across the galaxy in a very specific way. This is not a shout of light, but of microwaves amplified by an unlikely cosmic ingredient, water. Trillions of water molecules, energized by the intense radiation from a newborn protostar, are behaving like a vast natural laser, but for microwaves. We call this phenomenon a maser, an acronym for microwave amplification by stimulated emission of radiation. It works like a laser you might see in a presentation, but instead of creating a narrow beam of visible light, it generates an intensely focused beam of microwave radio waves. The process begins when the energy from the young star pumps up the water molecules, exciting them to a higher energy state. Then, a passing microwave photon of the right frequency triggers them. It stimulates the molecules to drop back down, releasing their stored energy as another identical photon. This creates a chain reaction, a cascade of identical photons all moving in sync, resulting in a coherent, powerful beam of microwave radiation that can be detected from thousands of light years away. These water masers are not just cosmic curiosities, they are invaluable tools for astronomers. Because the signal is so intense and focused, it acts like a brilliant beacon within the otherwise opaque clouds of a stellar nursery. By carefully measuring the tiny shifts in the frequency of this microwave light, a phenomenon known as the Doppler effect, scientists can map the precise motions of the gas swirling around the infant star. They can measure how fast it is rotating, trace outflows of material being ejected from the poles, and even calculate the exact distance to these far-flung regions of star formation with incredible accuracy. It is like having a set of hyper-precise radar guns aimed at the very heart of creation, allowing us to understand the dynamics of how a star is built from the inside out. This natural amplifier turns a simple molecule into a cosmic spotlight, illuminating the hidden, chaotic beginnings of a sun. Two brilliant spirals are locked in a cosmic dance that is stretching them to their limits. Known as the mice galaxies, this pair of colliding star systems presents a breathtaking vision of a future that awaits our own Milky Way. Located about 300 million light-years away, these two galaxies are named for the immense, streaming tails of stars and gas that trail behind them, giving the entire structure the appearance of a pair of running mice. These are not static sculptures, but a dynamic snapshot of a gravitational encounter unfolding over hundreds of millions of years. The long tails are the result of immense tidal forces, the same kind of pull our moon exerts on Earth's oceans, but operating on a galactic scale. As the two galaxies swing past each other, their mutual gravity pulls and stretches their spiral arms, drawing out vast rivers of material into the void. Each tail is a stellar highway carrying millions of stars and enormous clouds of hydrogen gas away from their galactic homes. This violent interaction is not purely destructive, it is also a phenomenal engine of creation. Within those long, graceful tails, and especially in the dense regions where the galaxy's cores are interacting, the collision is triggering a firestorm of star birth. The immense clouds of gas, compressed and shocked by the gravitational turmoil, are collapsing under their own weight. Brilliant blue clusters of newborn stars ignite like strings of cosmic pearls along the tidal tails, their intense light illuminating the surrounding gas. The cores of the galaxies themselves are blazing with the light of countless new stellar nurseries, turning what were once orderly spirals into chaotic, brilliant cauldrons of activity. The fate of the mice is sealed. They are destined to continue their gravitational dance, swinging past each other again and again, each pass drawing them closer. Over the next few 100 million years, their distinct shapes will be completely erased as they merge into a single, larger elliptical galaxy, a process that will ultimately quench the rampant star formation and leave behind a more sedate, featureless celestial island. This spectacular collision offers us a front-row seat to one of the most fundamental processes in galaxy evolution, a dramatic preview of the eventual merger between our Milky Way and the Andromeda Galaxy. That cosmic eye watches from 700 light-years away, a brilliant and haunting farewell. The Helix Nebula hangs in the constellation Aquarius, a colossal sphere of glowing gas so vast it appears to stare back at us across the interstellar void. This is one of the closest planetary nebulae to Earth, the final, beautiful act in the life of a star that was once very much like our own Sun. For billions of years, this star burned steadily, fusing hydrogen into helium in its core. But when it finally exhausted that fuel, its delicate balance collapsed. The star swelled into a furious red giant, its outer layers becoming so tenuous that they began to drift away into space, escaping the star's weakening gravity. What we see now is that expelled atmosphere, a trillion-mile-wide shroud illuminated from within. The central star, now a tiny, searingly hot white dwarf, floods this cosmic bubble with intense ultraviolet radiation. This energy strips electrons from the atoms of the gas, causing the entire structure to fluoresce with an eerie greenish-blue glow, the specific color of ionized oxygen. The nebula's structure is far more complex than a simple bubble. Intricate knots of dense gas and dust, each one larger than our entire solar system, pepper the inner rim. These comet-like filaments radiate outward from the central star like the spokes of a wheel, their heads dark and shadowed, their tails streaming away in the stellar wind. They are the last, dense clumps of the star's original atmosphere, resisting evaporation as they slowly dissipate into the darkness. At the heart of this luminous chaos lies the star's legacy, the white dwarf itself. This Earth-sized sphere of degenerate matter is all that remains of the stellar core, a diamond-like ember so dense that a single teaspoon of its material would weigh many tons on Earth. It will spend the next billions of years slowly cooling and fading, a dying cinder adrift in the shell of its own making. The entire Helix Nebula is a temporary monument, a cosmic flower that blooms for only a few tens of thousands of years before its glowing gases expand and fade beyond visibility. This is the future that awaits our own sun, a reminder that even the most constant lights in our sky are destined for a final, spectacular transformation. Rising from a sea of incandescent gas, three colossal towers pierce the void. These are the pillars of creation, iconic columns of cold gas and dust standing within the heart of the Eagle Nebula. They are not solid structures, but rather dense cosmic mountains resisting a hurricane of energy from nearby, newly formed stars. Their surfaces are sculpted by this relentless assault, with streamers of gas being boiled away into the surrounding vacuum. Within these dark, towering forms, the future is taking shape. Deep inside the coldest, densest pockets of the pillars, gravity is patiently at work, collapsing the gas into protostars. These infant suns are hidden from our view, their light absorbed by the very dusty cocoons that nurture them. The pillars are thus a cosmic paradox, both a stellar nursery and a structure actively being destroyed. Our understanding of their delicate beauty was forever transformed by the Hubble Space Telescope. Its famous image, captured in 1995, revealed the pillars in stunning, almost three-dimensional detail. For the first time, we could see the intricate textures, the finger-like protrusions, and the ethereal glow of the nebula gas. It was a portrait of creation that captured the public imagination. But Hubble's later observations, particularly in infrared light, allowed us to peer through the obscuring dust. These views unveiled a hidden universe, showing the young stars embedded within the pillars themselves, their brilliant light piercing the darkness that visible light could not penetrate. Yet this same stellar birth carries the seeds of the pillars' destruction. The most massive of the newborn stars, though not visible in the iconic visible light image, are pouring out intense ultraviolet radiation. This immense light is eroding the pillars, evaporating the gas away from the top down in a process called photoevaporation. Even more dramatic are the stellar winds, supersonic streams of charged particles that blast away at the structures like a cosmic sandblaster. Observations from other telescopes have since revealed shock waves and vast clouds of heated gas being blown off the pillars, evidence of their ongoing disintegration. It is a race against time. Will the fledgling stars deep within the pillars finish their formation and ignite before the protective gas around them is completely stripped away? Current estimates suggest that in a mere 100,000 to a million years, these majestic towers will be gone, vanished into the glowing background of the nebula, their material scattered to form new generations of stars elsewhere. The pillars of creation are a fleeting masterpiece, a temporary monument to the beautiful and violent cycle of stellar life and death. Its ferocious tendrils of glowing gas sprawl across 1,000 light-years, a cosmic spider weaving a web of brilliant new suns. The Tarantula Nebula is the greatest stellar nursery we have ever found, a sprawling factory of star birth that dwarfs any similar region in our own Milky Way. Located not within our galaxy, but in its orbiting satellite, the Large Magellanic Cloud, this nebula is the most active and violent star-forming region in our entire local group of galaxies. Its core is a blistering cavity, hollowed out by the hurricane-force winds of thousands of colossal young stars, all born from the same primordial cloud of gas. The sheer energy pouring from this single nebula is so immense that if it were as close to us as the Orion Nebula, it would cast shadows on Earth and be visible in our sky even during the day. At the heart of this celestial beast lies a true monster, a star that pushes the very limits of what is physically possible. Known as R13601, this is the most massive and luminous star ever catalogued by humanity. To grasp its scale, our own Sun is a mere candle flame in comparison. R13601 is a hypergiant, a stellar behemoth with a mass over 250 times that of the Sun, and it shines with the fury of nearly 9 million suns combined. Its surface roils at temperatures exceeding 50,000 degrees, and its fierce ultraviolet radiation is constantly eroding the very nebula that gave it life. Such extreme power comes at a terrible cost. Stars of this magnitude live fast and die young, burning through their nuclear fuel in only a few million years. Their final act is one of unimaginable violence. R13601 and many of its gigantic neighbors are living on borrowed time, destined to end their lives not in a gentle fade, but in the ultimate cosmic explosion, a supernova. Some may even become the rarest and most powerful cataclysms in the universe, hypernova, whose collapse could birth a black hole and unleash a focused jet of gamma rays capable of sterilizing entire galactic sectors. The Tarantula Nebula is therefore more than a beautiful cloud. It is a ticking time bomb and a spectacular laboratory, showing us both the furious birth and the spectacular, inevitable death of the universe's most extreme stars. A dying star has woven its final breath into a celestial kaleidoscope. The Cat's Eye Nebula stares back at us from 3,000 light-years away, a cosmic eye with intricate glowing rings that ripple outward like frozen waves. This is one of the most complex planetary nebulae ever discovered, a structure so layered and detailed it defies simple explanation. Unlike the Helix Nebula's vast bubble, the Cat's Eye is a dense, intricate maze of concentric gas shells, colossal jets, and mysterious knots of dense material. Its form suggests not a single, gentle exhale, but a star dying in violent, periodic fits and starts. The secret to this convoluted beauty likely lies in a cosmic dance at its very heart. Astronomers strongly suspect the central star is not alone, but is part of a binary system. The gravitational tug of war between these two stars would create a chaotic environment, causing the dying primary star to eject its outer layers not in a steady stream, but in powerful, episodic outbursts. Each pulse of material expands into space, only to be overtaken and shocked by the next eruption, creating the nebula's signature nested shells. The result is a fossil record of the star's final death throes, a timeline of its agony etched in luminous gas. Then there are the vast, high-speed jets shooting from the poles, and the inexplicable knots of gas that are so dense they cast long shadows out into the nebula. These features point to a dynamic and violent end, a farewell orchestrated by two stars locked in a final, transformative embrace. The Cat's Eye is more than a beautiful corpse, it is a cosmic clock, its intricate rings counting down the final millennia of a star's life with breathtaking precision. Its glowing contours resemble a celestial swan drifting on the currents of deep space. The Omega Nebula, also known as the Swan, is a colossal cloud of hydrogen gas and dust, a stellar nursery ablaze with the light of infant suns. Located between 5,000 and 6,000 light-years away in the constellation Sagittarius, this nebula is so large and bright that it can be glimpsed with binoculars under a dark sky, a faint, glowing smudge against the rich starfields of the Milky Way center. But this serene appearance is an illusion. The nebula is a cosmic pressure cooker, a region of intense and ongoing creation. The beautiful, luminous gas is not generating the light itself. It is being illuminated, fluorescing under a relentless bombardment of energy. Deep within the cloud, dozens of massive, young stars have recently ignited. These are stellar titans, many times more massive than our own Sun, and they burn ferociously hot. Their surfaces rage at temperatures of tens of thousands of degrees, blasting out immense amounts of ultraviolet radiation. This invisible, high-energy light slams into the surrounding hydrogen gas, stripping electrons from their atoms in a violent process called ionization. When those electrons eventually reunite with the atoms, they release the characteristic red glow that gives the nebula its vibrant color, a beacon of stellar birth visible across thousands of light years. The nebula is not just a passive backdrop, it is actively being sculpted by the very stars it spawned. The intense radiation and powerful stellar winds from these hot, young stars are pushing the remaining gas and dust away, carving out vast cavities and shaping the cloud into the familiar swan-like form. In the darkest, densest pillars of the nebula, the process is still underway. Gravity is tirelessly pulling together new clumps of gas, collapsing them into ever denser cores that will one day ignite and become new stars, continuing the beautiful, violent cycle of creation that defines this brilliant region of our galaxy. A dying star has left a perfect smoke ring hanging in the void. The Ring Nebula, known to astronomers as Messier 57, is perhaps the most iconic of all planetary nebulae, a celestial donut of glowing gas floating against the blackness of space. Its symmetry is so striking it almost looks manufactured, a cosmic piece of jewelry crafted from the final breath of a sun like our own. For generations, this was the textbook image of a star's gentle, spherical departure. Yet modern observations have revealed that this simple beauty is a magnificent illusion. When viewed in different wavelengths of light, especially with instruments like the Hubble Space Telescope, the nebula's true form emerges. It is not a simple ring at all, but a complex barrel-shaped structure. We are looking directly down the barrel's open end, with the central ring forming its brightly illuminated waist. The dark central region is not empty space, but the vast, transparent interior of this cosmic cylinder. Faint, fanning lobes extend above and below the ring, completing the three-dimensional shape. At the heart of this glowing sculpture lies the star responsible for it all, a tiny, intensely hot white dwarf. This stellar ember is what makes the nebula shine, its powerful ultraviolet radiation causing the expelled gases to fluoresce with vibrant color. The intricate patterns within the ring itself, the subtle variations in brightness, are like fossilized sound waves, a permanent record of the turbulent pulses and stellar winds that carved this structure as the star shed its outer layers. The Ring Nebula stands as a profound reminder that our perspective is everything, and that even the most seemingly simple objects in the cosmos hold hidden depths, their true nature waiting to be revealed when we learn to look at them in a new light. Its vibrant glow is a beacon of creation in the constellation Sagittarius. The Lagoon Nebula is a vast cosmic womb, a sprawling cloud of gas and dust so immense that it can be seen without a telescope from a truly dark sky, appearing as a faint, misty patch in the Milky Way's brightest regions. But this serene glow is the outer face of a turbulent interior. At its heart lies a brilliant, compact region known as the hourglass, a name that perfectly captures its pinched, double-lobed shape. This is not a quiet hollow, but a cavity being violently excavated. The sculptor is a single, tempestuous young star named Herschel 36, a stellar behemoth many times more massive than our Sun. This star is a cosmic blowtorch, radiating fierce ultraviolet light and hurling out powerful stellar winds. These forces are relentlessly pushing back the surrounding nebula material, carving out the hourglass and simultaneously compressing the gas at its edges, triggering the birth of even more stars in a self-perpetuating cycle of creation and destruction. The entire nebula is a dynamic battlefield where gravity's pull to form new stars is constantly challenged by the violent output of the stars already born. You are seeing a snapshot of a million-year war, a beautiful conflict that is building the next generation of suns and perhaps the planetary systems that may one day orbit them. That same celestial artistry paints a nebula that seems to split into three distinct parts, a cosmic canvas where light and shadow perform in perfect harmony. The Trifid Nebula, a name meaning divided into three lobes, is one of the sky's most stunningly complete portraits of stellar life and death. It is not one object, but three different types of nebulae existing in the same space, each telling a separate chapter of the same story. The most dramatic color is the deep, glowing red that dominates vast regions of the cloud. This is an emission nebula, a vast cloud of hydrogen gas that has been energized by the fierce young stars forming within it. The intense ultraviolet radiation from these stellar infants strips electrons from the hydrogen atoms, and when those electrons recombine, they release that specific, vibrant crimson light. It is the same process that lights a neon sign, but on a scale of trillions of miles. This red glow is the signature of raw stellar power, the visible shout of a nursery in the midst of creation. Yet, woven directly alongside this fiery red is a cooler, more serene blue. This is a reflection nebula, and its magic works differently. Here, the light from the same hot, young stars is not powerful enough to ionize the gas. Instead, it simply bounces off microscopic dust grains floating in the cloud. These tiny particles are far more efficient at scattering blue light, just like our own atmosphere makes the sky appear blue. So, the blue regions are not generating their own light. They are merely reflecting the starlight, showing us where the dust is cleanest and most abundant. Then there are the third and perhaps most crucial elements, the dark, obscuring lanes that give the Trifid its name. These are dark nebulae, dense, cold ribbons of dust so thick they completely block the light from the glowing regions behind them. They are not empty, they are the opposite. They are the raw, unused material of the nebula, the cold storage of cosmic ingredients. Within these dark lanes, gravity is silently at work, pulling the dust and gas together into ever denser knots. It is in these shadows that the next generation of stars is likely beginning to coalesce, hidden from view until their own light is powerful enough to push back the darkness. The Trifid Nebula is a single, breathtaking laboratory. In one glance, you witness the entire cycle, the brilliant emission of active star birth, the gentle reflection of starlight on the surrounding dust, and the dark, pregnant silence where future suns are just beginning to dream. A celestial forge glows just 1,500 light-years from Earth, a place where the very fabric of our galaxy is being woven anew. The Orion Nebula is the closest massive stellar nursery to our world, a churning cauldron of gas and dust where thousands of new suns are igniting. To the naked eye, it appears as a faint, fuzzy star in Orion's sword, but through a telescope, it unfolds into a breathtaking vision of creation. At its heart lies the brilliant Trapezium cluster, a tight-knit group of four immensely hot, young stars whose fierce ultraviolet radiation is carving out a vast cavity within the cloud. Their light acts like a cosmic blowtorch, causing the surrounding hydrogen gas to fluoresce with a soft pink glow, while simultaneously pushing back the darker, colder material that birthed them. This beautiful violence makes the nebula a perfect natural laboratory. We are witnessing the same chaotic processes that gave rise to our own solar system over 4.5 billion years ago. Within the nebula's darker, cooler filaments, gravity is tirelessly pulling together dense knots of gas and dust. These are protostellar disks, the swirling cradles of infant solar systems. Some of these disks are already showing gaps and rings, the telltale signs of newborn planets coalescing from the primordial chaos. The Orion Nebula offers a front-row seat to the entire life cycle, from the first collapse of a gas cloud to the ignition of a star and the eventual formation of its orbiting worlds. It is a dynamic and ever-changing environment, a snapshot of cosmic evolution happening in real time, reminding us that the universe is not a static museum but a living, breathing entity, constantly building new islands of light in the eternal dark. This final cosmic spectacle is a star system on the very brink of self-destruction. Eta Carinae, a hypergiant binary system, is one of the most massive and unstable stellar objects known to exist in our galaxy. Its two stars are locked in a frantic 5.5-year orbit, with the primary star containing the mass of at least 150 suns. The combined luminosity of this pair is staggering, blazing with the power of over 5 million of our own suns. For all its power, this system is most famous for a historic outburst in the 1840s known as the Great Eruption. For nearly 2 decades, Eta Carinae became the second brightest star in the entire night sky, a sudden and terrifying transformation that defied all understanding of stellar behavior. Astronomers of the era watched in awe, with no way of knowing they were witnessing a star tearing itself apart. The eruption was not a supernova, but a colossal stellar tantrum. The primary star ejected an enormous amount of its own mass, enough material to form several solar systems, at a speed of millions of miles per hour. This cataclysmic belch of stellar material did not simply drift away. It formed the Homunculus Nebula, a breathtaking bipolar cloud of gas and dust that now envelops the entire system. Shaped like a vast cosmic hourglass, this nebula glows from within, illuminated by the ferocious light of the central stars it hides. We now understand the Great Eruption was likely triggered by the violent interplay between the two massive stars. Their close orbits may have caused one star to dump a catastrophic amount of material onto the other, pushing it so far past stability that it violently expelled its own outer layers in a desperate survival mechanism. Today, Eta Carinae remains highly unstable, shuddering with X-ray flares and dramatic changes in brightness. The central stars are completely enshrouded by the very nebula they created, a self-made cocoon of cosmic dust. The ultimate question hanging over this system is not if it will explode, but when. It is a prime candidate for the next supernova in our galaxy, an event that could happen tomorrow or in 100,000 years. When it finally does go, it will be a spectacle unlike any other in recorded human history. For a brief period, it could outshine the full moon, visible in the daytime sky and casting shadows on Earth at night. Such a nearby supernova would flood our solar system with high-energy radiation. Though at its distance of 7,500 light-years, it is far enough to pose no direct threat to life on our planet. Eta Carinae is a ticking time bomb, a final, dramatic reminder that the cosmos is a place of beautiful, terrifying, and unimaginable power. 50 strange objects have revealed a galaxy of breathtaking extremes and profound mysteries. From the silent, crushing gravity of Sagittarius A, to the runaway fury of hypervelocity stars, our home is a cosmic theater of constant drama. We have wandered through stellar nurseries where stars are born in clouds of glowing gas, and we have witnessed the final, beautiful gasps of dying suns etched into planetary nebulae. We have seen galaxies collide, warp, and even form perfect rings from the chaos, and we have tracked the ghostly pull of dark matter and the whispers of long-dead quasars. This incredible diversity, from diamond planets to ancient stellar vampires, confirms one stunning truth: the Milky Way is not a serene and settled collection of stars. It is a dynamic, evolving, and deeply mysterious ecosystem. Its quietest corners hide ancient secrets, while its core roars with the energy of past cataclysms. Every one of these 50 objects is a piece of a puzzle we are only just beginning to assemble. So tell us, which of these cosmic oddities captured your imagination the most? Was it the ghostly echo of the wow signal, the perfect geometry of Hoag's object, or the ticking time bomb of Eta Carinae? Let us know your favorite in the comments below, and subscribe to continue the journey, because the universe still has countless more wonders waiting to be uncovered.